So the Net Zero 2.0 project evolved out of the work that we delivered with Hartlepool and Stockton councils in 2023. This was the next iteration of our low carbon solution. We were keen to focus on how we could fit that solution around National Highway's own strategic objectives.
This scheme is part of one of our deliverables in the asphalt decarbonisation roadmap. It's a pilot scheme to demonstrate how far we can go with modern day technology in decarbonising our roads.
We focused on how could we provide and enhance the solution that we delivered in 2023 to deliver and push boundaries further on the A64 project.
So one of the key levers to success on the A64 was about active collaboration with National Highways. We had three key objectives to deliver longer lasting, smoother and lower carbon roads. Early collaboration was really key to us achieving this. The first step we took with National Highways was to set a clear and accurate benchmark based on the objectives set out in their Net Zero roadmap. We then worked with National Highways at the design stage to provide them with carbon data ahead of the project. This allowed National Highways to optioneer and pick the right sustainable solution for this project. We then followed the principles of PAS 2080 throughout, measuring all fuel use on the site from quarry to construction to give us an accurate reduction in carbon throughout the project. Putting all of this together, we managed to achieve a 75% reduction in carbon across this project.
A key element of our overall solution for the A64 scheme was the material technology and the design.
Working with Shell, we introduced the latest evolution of the binder product, which combined their H-Safe extended life product together with the biogenic product that we'd used successfully in 2023, delivering low carbon as well as extended pavement life.
We fully expect that this surface course system will deliver 25% additional life over standard thin surface course systems.
By extending the pavement life, we reduce future maintenance interventions, and that reduced future maintenance intervention reduces carbon from removing that future construction activity. Secondly, it minimises disruption to the travelling public, and thirdly, it should reduce cost over whole life.
Smoothness is important as it reduces the amount of CO2 and energy required to move vehicles down the carriageway. Research has shown that up to a 7% saving can be made in actual fuel usage by using a smoother road rather than a conventional carriageway. To achieve this, we deployed a system called Multiplex, which in effect removed a lot of the undulations from the carriageway whilst we're planing, and we saw differences in milling depth from between 34 to 48 millimetres. That demonstrated the level of inaccuracy that was in the current carriageway, all of which was removed during the planing process.
So over the course of a full weekend closure, we had two pavers laying an echelon, material supplied through two feeders and continuous paving across 2.5 kilometres of carriageway. Material supplied out of Cross Green with a continuous feed of wagons meant that the paving train didn't stop from 8 AM through till 5 PM. And that was essential for us to deliver the high performance pavement.
This gave us a constant machine setup which enabled us to achieve the best possible results and give the best possible IRI for the travelling public. The existing carriageway was particularly poor and had an IRI well in excess of 2. We had a target of achieving under 2 for the scheme. In actual fact, we achieved an IRI of 0.9, which is comparable to a lot of test tracks which are currently under use in the UK.
The project was absolutely a success. We achieved the objectives that we set out to deliver. We've demonstrated that the collaborative environment of the two teams working together, changing that construction methodology, we've delivered a substantial improvement in productivity through that full weekend closure.